Hello everyone. It is my pleasure to have a chance to meet you all present the topic of port connectivity in theory and practice with particular reference to Korea, which has been organized by the Korean Cooperative Supporting Center for Overseas Port Development. Before I begin, I would like to introduce myself. My name is Hyung-Sik Nam, and I'm a professor in the Department of Logistics at the Korea Maritime and Ocean University. As I heard, this KCSC training session is normally conducted in person by inviting you here in Korea, and it is unfortunate that COVID-19 has forced us to conduct it online. However, I hope to have the opportunity to meet you in person in the future and to speak you in person someday. This presentation consisted of three main parts. In the first part, I will introduce the roles and the functions of transport under an international trade and logistics perspective. Main roles of international seaport in transport system will also be highlighted. Moving on to the second part, I will briefly introduce the status of container ports in Korea. The final part is the main body in today's lecture, and I will introduce the container cargo transport connectivity between ports and the container transportation using multimodal transportation. The first part of the lecture is about the freight transport system. In the logistics system, transportation is the part that accounts for the largest cost along with storage, and although there is a different depending on the country and the cargo being transported, is 40 to 50% transportation plays a key role in international trade under several perspectives, such as facilitated international production and distribution, level market prices and reduced inventory, facilitate lead time control, reconciliate trade-off between customer services and logistics cost, promote competition between regions. Ports are one of the most important infrastructure as they are responsible for promoting trade activities and supporting economic activities. As you can see in the diagram, port serves and important roles as transportation hubs that facilitates goods movement, the distribution of freight, including raw materials, parts, and finished consumers' products by all modes of transportation, including marine, air, rail, and truck. Multimodal transport or combined can be defined as the transportation of goods under a single contract, but performed with at least two different modes of transport. The combination can be CNC, CN land, and CN air. Each mode of transport has its own benefits. However, from a logistics point of view, the organization of logistics, which reduce the logistics cost and give customers that best satisfaction, is the transport cargo through multimodal transportation rather than relying on a single transportation method. The picture shows the three different components of port connectivity. There is a hinterland connectivity, foreland connectivity, and the gateway or hub port acting as a connector. A fundamental factor in the gateway or hub port is the global connectivity, which is the outcome of geographical factors, location, sea depth, etc. The hinterland connectivity enables each gateway to access its market area via freight corridor and different modal split, such as rail, road, and river barges. The foreland connectivity is the network which reflects the structure of international trade, its web of interactions. For example, how the port is connected with global air and maritime shipping networks. Let's start the second part of the lecture. I will introduce the status of container ports in Korea briefly. As you can see on the left, this figure summarizes the maritime profile of Korea. For Korea, maritime transport is extremely important for the economic growth of the country, and the maritime industry has been developed since 1960s. Therefore, Korea is a strongly maritime-oriented nation. In particular, Korea is an important ship-owning country, and it is a world leader in shipbuilding. This slide illustrates the total merchandise trade in Korea. I think it is important to show these statistics as can give you an indication on the containers, the importers, and the export, and how well connected Korea is overall on the seaside. You can see that since 2005, trade value in terms of million USD has almost doubled in year 2020. Export was 512,000 million USD and imports 467,000 million USD. The figure shows the port call and the performance of Korean ports by ship types. As you can see, in 2020, 73,000 ships called in Korean ports, of which 21,000 was container ships. For the container ships segment, the median time in port was 0.64, which indicates a very fast turnaround time. The average size in terms of TEU container ships was 3,056 TEU. In Korea, there are 4 representative container ports, namely Busan, Gwangyang, Incheon, and Pyeongtaek, based on annual container throughput. The largest of them is Busan Port, which is the 6th largest in the world. As of the end of 2020, the total throughput of Busan Port was about 21.8 million TEU. About 55% of container throughput, or 12 million TEU, was transshipment cargo. And for this reason, Busan Port is known as the world's second largest transshipment container port. As shown in the chart, China, the United States, Japan, Canada, and Russia were surveyed as representative partner countries connected to Busan Port. You can also see on the table on your right the container volume between Busan Port and the overseas port. In terms of volume, the most important pair port with Busan were China, Qingdao, Shanghai, Tianjin, Ningbo, and Dalian, and American, such as Long Beach, Los Angeles, Vancouver, Savannah in USA, and Mazatlan in Mexico. This is the end of part 1. Let's have a look at the port connectivities in theory and the practice with particular reference to Korea. When we talked about maritime connectivities of a port, we need to mention the liner shipping connectivities index developed by UNCTAD. You can see that statistics by countries that can be retrieved from UNCTAD website. However, I would like to explain in more details how the liner shipping connectivity index was developed and what elements were considered to build it up. The liner shipping connectivity index, shortly said LSCI, aims at capturing the level of integration into the existing liner shipping networks by measuring liner shipping connectivity. The index is calculated based on 6 major components. Firstly, scheduled ship calls concern the number of ships that are calling on a weekly basis. Their calls can either involve the import, export, or transshipment activities. Second, deployed capacity. The total capacity of these services enables to link port calls with the related physical capacity. The higher the capacity, the greater potential to trade on global markets. Third, number of shipping companies and liner services. How many shipping companies that are servicing the country or the port, as well as how many scheduled services they are using to provide this coverage. Fourth, average and the vessel size. The proxy to the available economies of scale, since they conveys the lower shipping cost per TEU. Directly connected ports, the number of ports that are directly connected to the referenced port. This figure shows the world map. The yellow dots represent the port liner shipping connectivities index. The bigger the dot is, the more connected that port is. As you can see, the most connected ports are located in Far East and Southeast Asia, Southern Europe, and Northern Europe. Something interesting in note is that there is a very high concentration of higher connected ports in specific world regions, and in particularly Far East Asia and Europe. The same picture also shows the countries' liner shipping connectivity index. Countries that have different colors, and the darker green a country is shown, the more that country is connected. You can see there is again a big difference among world regions. The Far East, Western Europe, and the USA are highly connected, whilst the developing countries are not so well connected. This indicated that developed countries are facilitated in international trade participations, whilst the developing countries are facing more challenges, and in particular island nations. The table on your left shows how well connected is Korea, while the list top 10 partners. Korea is best connected by sea with China with a score of 0.969. The maximum is 1, followed by Singapore, Hong Kong, Malaysia, Japan, the Netherlands, Spain, Germany, UK, and Belgium. On the right, the figure shows the liner shipping connectivity index from year 2002 to year 2020. The index has constantly been growing since 2006, showing a constant improvement of the index over the years. The figure shows the liner shipping connectivity index for the top 5 Korean ports. On the top, in dark blue color, you can see that Busan is the most connected port by far. This is very important for Busan, as Busan is a major transshipment port in the Far East and needs to be very well connected to serve different markets and customers. This is a more detailed table showing the liner shipping connectivity index scores for the major Korean ports in 4 quarters of 2020. As we have already said, among Korean ports, Busan has the highest port liner shipping connectivity index for year 2020. The score from the first quarter to the fourth quarters of 2020 were 118, 116, 117, and 118. The second most connected port is Gwangyang with a score of 60. So, as you see, there is a large gap between Busan port and the other Korean ports. Also, at an international level, the port of Busan is ranking among the top connected ports. As mentioned before, Busan Port, which recorded the largest throughput in Korea, handled about 20.9 million TEU as of the end of year 2020. In Korea, about 92% of container and from Busan Port were transported by road, 60% by coastal transport, and only 20% by rail. In other words, most containers in Korea are transported by road. This means that as a peninsular country, container transportation using rail has no or only little price competitiveness due to a relatively small land size. However, the current poor utilization of coastal transportation is considered to be a matter of improvements, as Korea is a country bordering 2 seas and the relatively good port facilities. However, let's take a look at how the Netherlands and Germany have developed the hinterland connectivities and how the modal split is distributed. I'm introducing 2 ports in which hinterland modal split is well distributed. Rotterdam is a major container port located in Northern Europe. The cargo traffic composition is around 65% for hinterland and 35% for transshipment. The hinterland modal split is distributed between road for 64%, inland waterway transport for 35%, and rail for 11%. This is important as rail and inland waterway combined represent 46%, nearly almost half, of the container moving in and out of the port. The port is able to reduce congestion and emissions thanks to the modal split is the suspicion. Hamburg port also one of the major container port in Europe. I'm showing this case because it is similar to Rotterdam in terms of shares of modal transport to the hinterland. Road represents only 40%, rail 51%, and river barges 9%. So more than half of container moving in and out of Hamburg are moved by rail and barges. This is not common for port worldwide, as containers are mostly moved by road. Before looking at the peculiarities of modal transportation related to the port's hinterland connectivities, let's take a look at the flow of container handling within a container ports. The figure illustrates the uploading and the loading process at the typical container terminal. Unloading processes can be divided into three different sub-processes. When a ship arrives at the port, container cranes or quick cranes takes the import containers off the ship's hold or off the deck. Next, the containers are transferred from the containers cranes to vehicles that traverse between the ship and the stack. After a certain period, the containers are retrieved from the stack by crane and transported by vehicles to transportation modes like barges, deep-sea ship, trucks, or train. Both automated guided vehicle and straddle carriers move the containers from quayside to container yard. The difference of two equipment is its use. Automated guided vehicle is commonly used in the automated port such as Rotterdam, Qingdao, etc. The most common use of straddle carriers is in port terminals and intermodal yards, where they are used for stacking and moving ISO standard containers. During the container transfer within the yard storage stacking cranes and floor track container stacking cranes are frequently used. All major container ports have a rail track within the port area and allow to transfer container to their final inland destination. Container movement by road is the most convenient method, and truck specification for 20-feet containers is around 10 to 12 meters length, 4.5 meters height, and 3.5 meters width. The truck can also move two 20-foot containers or one 40-foot containers. Advantages of multimodal transportation using rail include a transport cost is relatively low and economical for long distance. In long distance, mass and high-speed transportation is possible and can avoid traffic congestion and not greatly affected by climate. In addition, it is an environmental friendly transport mode. However, disadvantages are also recognized as requires the transshipment work and special equipment and door-to-door delivery services unavailable. Container transport through the rail is either performed through trailer on flat car system or container on flat car system. For the TOFC system, a floor track container stacking crane or reach stacking cranes are needed to load container boxes into train. As mentioned earlier, the biggest disadvantages of a train in multimodal transport is that they require the equipment such as cranes. To improve this, a technologist called dual mode trailer, such as bimodal, modular, and cargo dominer has been developed, and some of them are currently being used mainly in the US and Europe. Road trailer is a trailer or semi-trailer that can be hauled on roads by a tractor unit and then by way of a fifth wheel coupling, operates in a unit train on railway lines. Modalist system uses special railways wagons of a type known as piggyback wagons to carry standard load semi-trailers on the European rail network. The cargo dominer has been in commercial use in Switzerland since 2002 as a method of horizontally loading and unloading containers or trailers. Double stack rail transport is a form of intermodal freight transport in which a railroad cars carry two layers of intermodal containers. Invented in the United States in 1984, it is now being used for nearly 70% of United States intermodal shipments. An inland container depot or dry port refers to a complex logistics terminals and an inland container barge equipped with the scale and facilities for connecting two or more modes of transport. The main objectives of constructing an ICD is to reduce logistics cost by collecting and transporting a large amount of cargo at once. While the demand for transportation of cargo is rapidly increasing, the logistics facilities are insufficient, and this caused the increasing of companies' logistics cost and weakening the nation's competitiveness. It is necessary to build an interconnected transport network that transports large quantities of small and frequent cargoes of various types. So, inland logistics bases such as ICD were built at the nation's 5 major logistics hubs. Since the services of Uiwang ICD started on the outskirts of Seoul, the capital of Korea, in 1993, a total of 5 ICD for each region have been built, and 2 are currently under construction. This is the end of the presentations. We looked at port connectivities in theory and the practice, focusing on Korea. In the logistics system, transportation is the part that accounts for the largest cost along with storage, and although there is a different depending on the countries and the cargo being transported. Through today's lecture, we looked at the system in which containers arriving through a port are transported to other ports or through inland transportation to their final destination. It was confirmed that it is necessary to establish an optimal multimodal transport modes system between port and the inland for the optimization of logistics. I hope this presentation will give you some benchmark points to be considered in your country's freight transport system. Please do not hesitate to contact me at hsnam@kmou.ac.kr if you have questions regarding the presentation. We hope for sharing growth through continuous exchanges in the future. Thank you for being with us. 감사합니다.